All right, so get this. Right under our feet, there's this incredible story, a story that's 4.6 times billion years old. It's a whole epic tale of fire, ice, huge disasters, and the rise of life. And today, we're going to learn how to read it. So let's start with maybe the greatest cold case of all time, the disappearance of the dinosaurs. I mean, we're talking about a 66 million-year-old whodunit. And the crime scene? Well, it's the entire planet.
Now, to solve a puzzle this old, we've got to become geological detectives. The clues aren't going to be fingerprints or DNA. Nope. They're buried deep inside the Earth, in all these different layers of rock.
And here's the really cool idea that geologists work with. They basically think of the ground beneath us as a gigantic history book. And every single layer of rock, that's a page, and it's preserving a specific moment in time.
And just like any good book, some pages are way more dramatic than others. These huge events, like a massive volcano erupting or an asteroid hitting, they write entire chapters in one single, dramatic instant. To give you a modern example, just think about Mount St. Helens back in 1980. That thing blasted a colossal cloud of ash into the atmosphere, which then settled over this huge area. That one event created a brand new, very distinct page in Earth's history book, a thin layer of ash that we can still go out and find today. But okay, before we can really start reading this book, we have to know the most basic rule. It's like the grammar of geology. It's called the principle of superposition. And honestly, it's brilliantly simple.
It's kind of like a laundry basket, right? The stuff you wore a week ago, that's buried at the bottom. The shirt you just tossed in there this morning, that's sitting right on top. And, believe it or not, rocks work in pretty much the exact same way. The oldest layers are way down deep, and the youngest ones are right up at the surface. That simple idea, well, that's the key to everything. So now we know the book is ordered from youngest to oldest. We know that as we dig down, we're literally going back in time. Let's use that knowledge and try to find the exact page where the dinosaurs just disappear. So as scientists were searching, they found something just extraordinary. A clue that wasn't just in one place, but all over the world. A single global fingerprint of some catastrophic event, the smoking gun.
And that clue was a chemical element called iridium. Now, iridium is incredibly rare in the rocks that make up Earth's crust, but it's super common in things like meteorites and asteroids. You can almost think of it as cosmic dust.
And all around the globe, I'm talking from Italy to New Zealand, scientists found this thin layer of clay that was just packed with this cosmic iridium, and when they dated it, it was precisely 66 million years ago. This was a page in the history book like no other. And this is what tells the story so perfectly. In the rock layers right below this iridium line, you find dinosaur fossils everywhere. The world is just teeming with them. But in the layers directly above it, nothing. They're just gone. The entire story changes in an instant, on this one iridium-dusted page. Layers that are this distinct and this widespread are so important, the geologists actually have a special name for them. They act like bookmarks, letting us line up the pages of Earth's history from literally anywhere on the planet.
They're called key beds. A key bed is just a unique layer, something formed by a single big event, that we can use as a time marker. It's how you can prove that rocks in, say, Colorado and rocks over in Spain were formed at the exact same moment in history. So remember that layer of ash from Mount St. Helens? That's a key bed. And that global layer of iridium from the killer asteroid? Well, that is the ultimate key bed, marking one of the most dramatic moments in our planet's entire history.
So how does all this build a complete timeline? Well, geologists can find a key bed in one part of the world and then go find that exact same key bed on a totally different continent. And because they know that layer represents the exact same moment in time, they can line up all the rock layers above and below it and start piecing together a continuous global history. And when you do this over and over and over again, with thousands of geologists working for decades, using countless key beds and other clues, you end up with something incredible. A complete timeline of our planet's history. And this is it, the grand result of all that detective work, the geologic timescale. It's the complete history book of Earth, compiled from all those individual pages that we found in the rocks. And just like our own calendars have years, months, and days, this huge timeline is organized into units. The biggest are eons, which are broken down into eras. Eras have periods, and periods have epochs. And each one of those boundaries, like the one between the dinosaurs' Mesozoic era and our Cenozoic era, it often marks a really dramatic change in life on Earth, like a mass extinction.
The scope here is just breathtaking. I mean, it covers everything, from the formation of the planet itself to the very first spark of life, the rise and fall of the dinosaurs, and all the way up to this exact moment. But the sheer scale of it is so hard to wrap your head around. 4.6 billion years. It's a number so massive, our brains aren't really built to even comprehend it.
Yeah, it's really tough to grasp that kind of time unless you can somehow relate it to your own experience. So let's try and do that right now. Okay, look at this. The first really long bar represents all of geologic time. Now see that second bar, that tiny, almost invisible sliver right next to it? That is the entire history of our species, Homo sapiens.
But check this out. This is probably the best way to really feel it. Imagine if we could squeeze all 4.6 billion years of Earth's history into just one single 24-hour day. If we did that, the dinosaurs, they would have vanished at about 11:40 p.m., okay? So what about all of human history, our entire story, everything we've ever done? It all happens in just the last couple of seconds before midnight. We're literally the last word on the last page of this giant, enormous book. Kind of makes you wonder, right? What's the next page going to say?